Alright, in this video I'll be solving my 9709 Pure 1 May June 2025 guest paper. If you're feeling anxious, overwhelmed, or unsure where to start, then I've created a complete course that streamlines everything with step-by-step videos, interactive quizzes, and an exclusive student community to keep you on track. You can get access to it by clicking the first link in the description. Otherwise, like the video, subscribe, and let's dive right in. Question number 1. In the expansion of ax plus 3 over x squared to the power 6, where a is a positive constant, the coefficient of 1 over x cubed is 67.5. Find the value of a and hence find the term independent of x in the expansion. Okay, so we are told that the coefficient of the term in 1 over x cubed is 67.5. So how would we find the term in 1 over x cubed? Of course, we want to use our formula for binomial expansion, which is a plus b to the n is equal to a to the n plus n choose 1, a to the n minus 1, b to the 1 plus n choose 2, and so on, right? We could do that. We could just use this formula directly and just fully expand everything. But one way to think about it is we just want the term in 1 over x cubed. So if this is our a and this is our b and this is our n, how can we use that information to just get the term in 1 over x cubed? So what if we raise our ax to the power, we can do to the power 3 here, and then our 3 over x squared, this has to be raised to the power 3 as well, because 3 plus 3 should give us our 6 here. Okay, our powers should add up to n. And if you can see from the formula here, this value on n choose is always going to be the power of b. So our power of b is at 3, so it means we've got n choose 3. N choose 3, but remember our value for n is 6, so we can just say 6 choose 3. Okay, so that's going to be 6 choose 3. Let's simplify our coefficient. What is 6 choose 3? 6 choose 3 is 20. So we've got 20 times a cubed x cubed. Alright, multiplied by 3 cubed, which is 27, over x squared to the power 3, that gives us x to the 6. And when we cancel out our powers here, you should notice that this x to the power 3 cancels out and you remain with a power 3 in the denominator, which is exactly what we're looking for because we want 1 over x cubed. So now we've got 20 times 27, so that's 540 a cubed, and this is times our 1 over x cubed here, 1 over x cubed. So we can tell that the coefficient of 1 over x cubed is 540 a cubed. So what this means is that 540 a cubed must be equal to 67.5, which we can write as 135 over 2. Okay, and now we're just solving for a. So that means our a cubed is going to be 135 over 2 multiplied by 1 over 540. So a cubed is equal to, let's punch this into the calculator, 135 over 2 times 1 over 540, that gives us 1 over 8. So if we take the third root on both sides, we should get that a is equal to 1 over 2. Alright, so we found the value of a. But now they also want the term independent of x. So to get the term independent of x, we want our x's to cancel out. So if we are going to say that we've got ax and we've got 3 over x squared, what powers do we have to give each bracket for the x's to cancel out? We could do a 4 here so that we'd end up with x to the 4, and a 2 here so that we'd end up with x to the 4 in the denominator. We should cancel out, and remember 4 plus 2 should be equal to n, which is 6. Alright, and so this becomes n choose r, so 6 choose, the r is always going to be the power on b, so 6 choose 2. 6 choose 2 is 15, and then we've got a here. Since we have evaluated a, I'll stop writing it as a, but as 1 over 2. So this is 1 over 2 x, and I'll keep the 4 outside just for now. So this is 3 over x squared squared. Let's simplify. So that's 15 times, then you're going to raise the 1 over 2 to the power 4. So 1 over 2 to the power 4, that gives us 1 over 16. Then raise the x to the power 4. And then here we've got 3 squared, which is 9 over x squared squared, so x to the 4. Alright, so the x to the 4 should cancel out, and then we've got 15 multiplied by 1 over 16 multiplied by 9, which gives us 135 over 16. Okay, so we can conclude that a is 1 over 2, and term independent in x, independent of x rather, of x is 135 over 16, and this would be our final answer. Number 2, show that the curve with the equation y squared plus 2xy minus 15 equals 0 and the line with the equation 3x minus y plus k equals 0 meet for all values of the constant k. So this is a discriminant question, and because they said meet for all values of the constant k, it must mean our discriminant b squared minus 4ac must be greater than 0 for all values of k. For all values of k, and this is essentially all we have to prove for all values of k. So we have to find our b squared minus 4ac, and we have to show that it is indeed greater than 0 for all k. So let's do that. So we've got y squared plus 2xy minus 15 is equal to 0, and we also have 3x minus y plus k is equal to 0. So initially we want to solve these two equations simultaneously and then reduce to a 3-term quadratic. So the way we're going to do that is we want to make y subject of the formula in this equation, so that it's y is equal to 3x plus k. Then we're going to replace the y here with our 3x plus k. So that's going to be 3x plus k squared plus 2x times 3x plus k minus 15 is equal to 0. And now we can go ahead and expand. So 3x squared, square the 3, that's 9, square the x squared. Then we've got 2 times 3x, which is 6x times k, so plus 6kx. Then we've got k squared. Then here we've got 2x times 3x, which is 6x squared. Then we've got 2x times k, which is 2kx minus 15 is equal to 0. Right, let's simplify like terms. We've got 9x squared plus 6x squared. That gives us 15x squared. Then we've got 6kx plus 2kx. So that's 8kx. Then we've got k squared minus 15 plus k squared minus 15 is equal to 0. So our a, the coefficient of x squared, is 15. Our b, the coefficient of x, is 8k. And our c, the term independent of x, is k squared minus 15. And now we can substitute into our discriminant b squared minus 4ac. So that becomes 8k squared minus 4 times a, which is 15, times c, which is k squared minus 15. Okay, and this is essentially what we have to prove is going to be greater than 0. All right, so square the 8, that's going to be 64. Square the k, that's k squared. Then we've got minus 4 times 15, that's 60, multiplied by k squared minus 15. Okay, so this is 64k squared minus 60k squared. That's 60 times 15. What does that give us? That's 900. 900. So 64k squared minus 60k squared gives us 4k squared plus our 900. Okay. Hopefully here you can see that this 4k squared plus 900, which is representing b squared minus 4ac, is always going to be positive, because for whatever value of k you put in here, it's going to be squared. So it means the 4k squared part is always going to be positive. And so if you're adding a positive part to a positive part, it means that this will always be greater than 0 for all values of k. And because this is representing b squared minus 4ac, it means that b squared minus 4ac will always be greater than 0. And if b squared minus 4ac is always greater than 0, then it means that the curve and the line intersect for all values of the constant k. Okay, of the constant k. And we've proved this. Number 3. Solve the equation 3 tan squared theta is equal to 4 over tan squared theta minus 11 for theta is between 0 and pi. Alright, so we've got 3 tan squared theta is equal to 4 over tan squared theta minus 11. Let's multiply through by tan squared theta to get rid of the denominator. So that's 3 tan to the 4 theta is equal to 4 minus 11 tan squared theta. Let's put everything on one side. So that's 3 tan to the 4 theta plus 11 tan squared theta minus 4 is equal to 0. Okay, we can rewrite tan to the 4 theta as, this is just the same as 3 tan theta to the power of 4, which in other words is the same as 3 tan squared theta squared, because 2 times 2 gives you this 4 here, plus our 11 tan squared theta minus 4 is equal to 0. Hopefully you can see that this is a hidden quadratic, so we can use a substitution to say that let y equal tan squared theta. And so this becomes, wherever there's a tan squared theta, you're going to replace it with y, so it becomes 3y squared plus 11y minus 4 is equal to 0. Okay, and now hopefully you can clearly see that we've got a quadratic equation. And I think we can factorize this quadratic by side by saying 3y times 4, which gives us 12y minus y. Okay, because 3y times 4 gives us 12y, then minus 1 times y gives us minus y. So 12y minus y gives us 11y. And then minus 1 times 4 gives us negative 4, so that's correct. Okay, so you get that either 3y minus 1 is 0. If you don't know how to factorize this by side, feel free to use quadratic formula or the completing the square method, whatever method works for you. Okay, and then here we also have that y plus 4 is going to be 0. So it means here that 3y is equal to 1, so y is equal to a third. And then in this case, we get that y is equal to negative 4. But remember that y is just a placeholder for tan squared theta. So we can rewrite both these equations as tan squared theta is equal to 1/3 and tan squared theta is equal to negative 4. And then we can solve our equations separately. So I'm going to start with this one and we're going to do it on the side. So that's tan squared theta is equal to 1/3. So the first step is to get rid of this power 2, and to do that you have to take the square root of both sides. But remember, when you take the square root, we get plus or minus. So it's tan theta is equal to plus or minus root 1/3, which we can separate into two separate equations. So we've got either tan theta is negative root 1/3 or tan theta is positive root 1/3. We'll start with the negative one. You get that theta is arctan of negative root 1/3. And so whatever we get here, we call this our principal value. And let's just check what our interval looks like. We want theta to be between 0 and pi. Okay, so that means we are in radians, and we want arctan of negative root 1/3, and this gives us, that's negative 1/6 pi. So we can use the formula PV plus pi n, where n is an integer, to check if we're going to get any solutions within the interval. The interval is theta must be between 0 and pi. So for example, at n is 1, we can say that our principal value, which is negative 1/6 pi, plus pi times 1, what would this give us? So that's going to be negative 1/6 pi plus pi times 1. It gives us 5/6 pi. And is 5/6 pi within this interval? Yes, it is. So this is going to be one of our solutions. If you check it n is equal to 2, you're going to get a solution that's outside the interval, but you're welcome to check it n equals 2. So this 5/6 pi is the only solution we get from this equation over here. So let's evaluate the positive one. So that's going to be theta is equal to arctan of positive root 1/3 rather. So our principal value is going to be, that's arctan of root 1/3, and that's 1/6 pi. Is our principal value within the interval 0 to pi? Yes, it is. So it's going to be a solution as well. And we can check to see if there are any other solutions using this same formula over here. So we can say at n is equal to 1, that's going to be 1/6 pi, which is our principal value, plus pi times 1, and this is going to give us 7/6 pi, which is bigger than pi, right? So it means that this is outside of our interval. So it would mean that from these two equations here, so far we've gotten that theta is going to be 1/6 pi here, or that theta is 5/6 pi. Those are the two solutions we have so far. And then we had another equation here, which is tan squared theta is equal to negative 4. So here what you'd have to do is, to get rid of this power 2, you take the square root of both sides. Okay, don't forget plus or minus. But now we've got a problem. Here we're taking the square root of negative 4. So the square root of negative 4, if you try to punch it into your calculator, you get an error. So we have no solutions here. We can say that theta is equal to no solutions. Okay, so it means this equation here does not give us any values for theta. So our final answer is going to be theta is 1/6 pi or 5/6 pi. Number 4, a function f with domain x is greater than 0 is such that f of x is equal to 16/3x cubed plus 1/x plus 10/3. Part A, find the coordinates of the stationary point. So to get the coordinates of the stationary point, the idea is that the first derivative dy dx is equal to 0. In this case, since they've given us in f of x is going to be f prime of x is equal to 0. So we need to find what f prime of x is, and then we're going to equate that to 0 and solve for our x coordinate. Okay, so let's do that. So we want f prime of x, that's going to be equal to, we'll start by differentiating this term. So bring down the power 3 times 16/3 x, subtract 1 from 3, you get a 2. And then this 1/x here, that's the same as x to the negative 1. So bring down the negative 1, x, subtract 1 from negative 1, so you get negative 2. Then you've got plus 10/3. That's a constant. If you differentiate a constant, you get 0. So that means f prime of x is equal to, it's going to cancel out here. So you've got 16x squared, and then that's minus 1 over, I'll bring the x minus 2 to the denominator, so it becomes x squared. Alright, so we found our f prime of x, and we said we should equate it to 0. So 16x squared minus 1 over x squared is equal to 0, and we have to solve. So let's multiply through by x squared to get rid of our denominator here. So that becomes 16x to the 4 minus 1 is equal to 0, and now we're just solving for x. So we get 16x to the 4 is equal to 1, so x to the 4 is equal to 1 over 16. So we have to take the fourth root on both sides. Okay, remember you get plus or minus if it's an even root that you're taking. So x is equal to, that's going to be, this is the fourth root of 1 over 16, and this gives us plus or minus 1 over 2. But notice that our domain says x is greater than 0. So it means our x coordinate for this stationary point is going to be 1 over 2, because that's the one that's greater than 0. And now we have to find the corresponding y value. So to do that, we can use the equation of the curve. So we're saying our y value is going to be equal to 16 over 3, replace x with 1 over 2. So that's 1 over 2, and this is cubed, plus 1 over x, so 1 over 1 over 2, plus 10 over 3. Let's punch this into the calculator. We get that's 16 over 3 times 1 over 2 to the power 3 plus 1 over 1 over 2 plus 10 over 3, and this gives us a 6. So therefore the coordinates of our stationary point are going to be 1 over 2, 6, and that's our final answer. Part B says determine the nature of the stationary point. So to determine the nature of a stationary point, we need to first find the second derivative. So in this case, that's denoted by f prime prime of x. And this is going to be, you get that by differentiating your f prime of x. So start by differentiating 16x squared. So bring down the 2 times 16x, subtract 1 from 2, you get a 1. And then we've got here this negative 1 over x squared is the same as negative x to the negative 2. So we've got negative 1, bring down the negative 2, so that's negative 2, and then x, subtract 1 from the power, so negative 2, negative 1, that's going to give us a negative 3. So that means our f prime prime of x is going to be, that's 2 times 16, which is 32x, plus minus 1 times minus 2, so plus 2, and this is over x cubed. We want to evaluate it at our stationary point, so at x is equal to 1 over 2. At x is 1 over 2, so f prime prime of 1 over 2 is going to be, that's 32 times 1 over 2 plus 2 over, that's 1 over 2 cubed. Let's punch this into the calculator. This is going to be equal to, that's 32 times 1 over 2 plus 2 over 1 over 2 cubed, and this gives us a 32. So our second derivative here is positive, so that's greater than 0 at our stationary point, so at half 6. This means that this is going to be a minimum point, hence it is a minimum point, and that will be our final answer. Number 5. The diagram shows a metal plate OABCDEF consisting of sectors of 2 circles, each with center O. The radii of sectors AOB and EOF are 3 r centimeters, and the radius of sector COD is r centimeters. Angle AOB is equal to angle EOF, which is theta radians, and angle COD is 2 theta radians. It is given that the perimeter of the plate is 20 plus 16 over 3 pi centimeters, and the area of the plate is 40 over 3 pi centimeters squared. Given that r is greater than 7 over 4 and theta is less than 5 over 4, find the exact values of r and theta. So the way we're going to do this is to use this information that they've given us. They've given us the perimeter and they've given us the area. So they're saying that the perimeter is equal to, that's 20 plus 16 over 3 pi. So let's create an expression for our perimeter in terms of r and theta, and then we're going to equate that to 20 plus 16 over 3 pi. So we can say our perimeter is equal to, so it's going to be from O to A, right, the line OA, plus we've also got O to F. But notice how OA and OF are both the same because they're the radius of the large sector. So I can just write 2 times OA instead of writing OA plus OF. And then we've also got the arc AB, which is this arc here. And notice how this arc is also going to be the same as the arc FE or EF, if you will. So I can just write 2 times arc AB as well. And then we are going to have BC. So BC, and BC is also going to be the same as ED. So I can just write 2 times BC. And then what remains is going to be our arc CD. So plus arc CD. Alright, perfect. So now we need to find each of these lines and arcs in terms of r and theta. Remember, the formula for arc length is S is equal to r theta. So it means our perimeter is going to be equal to 2 times OA. OA is the radius of the large sector, so it's got a length of 3r. And this is plus 2 times arc AB, so it's radius times angle. So what's the radius of arc AB? The radius is 3r, and the angle is theta. So 3r theta plus 2 times BC. So for BC, notice how BC is going to be your OB, which we know to be 3r, minus our OC, which we know to be r. So OB minus OC gives us BC. So that's 3r minus r, which gives us a 2r. So you can say that this is 2r plus arc CD. So arc CD, that's this arc here that has a radius of r and an angle of 2 theta, like that. So this is our perimeter. Let's just simplify it. So our perimeter is going to be equal to 2 times 3r, so 6r, 2 times 3r theta, so 6r theta, then 2 times 2 times r, so 4r, and then r2 theta, so 2r theta. So perimeter is equal to, that's 6r plus 4r, so that's 10r, plus 6r theta plus 2r theta, so that's 8r theta. Okay, and so because we know that our perimeter is equal to 20 plus 16 over 3 pi, we can say that 20 plus 16 over 3 pi is equal to 10r plus 8r theta. And we can leave this equation here for now, and then we can do the same for area. So the area of the plate is going to be equal to, we've got, just going to delete these lines here. We've got this sector, the sector AOB, looks like this, and like that. And it's going to be the same as well as the sector EOF. So we can say that the area of our large metal plate is 2 times sector AOB. Okay, because AOB plus EOF is the same as 2 times sector AOB. Then we're going to have our small sector OCD, the small sector. So that's plus sector OCD or COD if you will. So we have to find the areas of these sectors. So we'll start with AOB. Remember that the formula for area of a sector is going to be equal to, that's half r square theta. So it means that for sector AOB, we're looking at half times the radius squared. The radius is 3r, so it's 3r squared times our angle. Our angle is going to be theta, so times theta, plus for sector COD, again it's a sector, so we're looking at half times the radius squared. The radius is r, so half times r squared, times the angle in this case is 2 theta, so times 2 theta. Alright, so let's just simplify this. We're saying that our area here is equal to, that's 2 times half, that cancels out. Then here square the 3, you get 9, square the r, that's r squared, and that's times theta. Plus, here the half and this 2 cancel out, so you remain with r squared theta. And these two are like terms, so we can add them together. It's just 9 plus 1, so that's 10 r squared theta. And we're saying that this must be equal to the area of the metal plate. So that's going to be 40 over 3 pi is equal to 10 r squared theta. So we can make theta subject of the formula here and say that theta is equal to 40 pi over 3 over 10 r squared, which we can write as theta is 40 pi over 3 times 10 r squared, and we can simplify so that it becomes theta is equal to 4 pi over 3 r squared, because 40 over 10 would just be 4. Alright, so now notice how we've got these two equations in terms of r and theta. So we've got this first equation that we got from our perimeter, and then we have this second equation that we got from our area. So we can solve these two equations simultaneously to find both our theta and our r. We've already made theta the subject of the formula in this second equation, so we can just replace this theta here with 4 pi over 3r squared. So this becomes 20 plus 16 pi over 3 is equal to 10r plus 8r times 4 pi over 3r squared. Notice how this power 2 and the r are going to cancel out, so you end up with 20 plus 16 over 3 pi is equal to 10r. Then here you've got 8 times 4 times pi, so that's 32 pi in the numerator. Then the denominator is 3r over 3r. Now we want to get rid of our denominator 3r, so we have to multiply through by 3r. So 20 times 3r gives us 60r, plus 16 over 3 pi times 3r gives us 16 pi r, and then 10r multiplied by 3r is going to be 30r squared, and then this just becomes 32 pi. Let's put everything on one side so that we've got 30r squared. Move both these terms to the right, so it becomes negative 60r, negative 16 pi r, and this is plus 32 pi. This is all equal to 0. And now I just want to factor out an r in these two middle terms, so that is 30r squared plus negative 60, negative 16 pi r plus 32 pi is equal to 0. Hopefully you can see that what we have here is a quadratic in terms of r, And remember that pi is just a constant. It's just the same as any other number you can have in your quadratic. So don't think pi is a variable. We are not solving for pi. It's a constant. So here we can say that a is the coefficient of r squared, so a is 30. B is the coefficient of r, so it's negative 60, negative 16 pi. And then c is the term independent of r, so c is 32 pi. To solve this quadratic that we have, if you're brave, you can attempt to factorize this, and yes, it does factorize, but I'd advise that for most of you in this case, use the quadratic formula. So we're going to say r is equal to minus b, so that's going to be positive 60 plus 16 pi, and then plus or minus the square root of, that's our b squared, so negative 60, negative 16 pi squared, minus 4 times a, which is 30, times c, which is 32 pi, and this is all over, that's 2 times a, so 2 times 30. Alright, so you get r is equal to, let's punch this into the calculator. I'll start with the negative one. So 60 plus 16 pi minus the square root of negative 60, negative 16 pi squared minus 4 times 30 times 32 pi, and this is over 2 times 30. This gives us, you get 8 over 15 pi. Okay, and then if we use the positive sign, so 60 plus 16 pi plus the square root, you get positive 2. Okay, I think we're at a condition that would allow us to disregard one of these two values. I just want to get an approximate decimal value for 8 over 15 pi, so we can see if we can accept it. This is 1.676, and we've got r is 2. We are told that r must be greater than 7 over 4, so r must be greater than 7 over 4 is 1.75. So this means we are disregarding the 8 over 15 pi since it's less than 1.75, and we can say that r is equal to 2. Okay, so if r is equal to 2, what is theta? We know that theta must be equal to 4 pi over 3r squared. So theta must be equal to 4 pi over 3r squared. So at r is equal to 2, theta is going to be, that's 4 pi over 3 times 2 squared. So theta is equal to, that's going to be 4 over 3 times 2 squared, which gives us just a third pi. So we can conclude that therefore r is 2 and theta is a third pi, and that is our final answer. Number 6. A curve passes through the point 2/3, 2/3, and is such that dy dx is equal to negative 12 over 3x minus 5 squared. Part A. Find the equation of the curve. So we are given that dy dx is equal to, that's negative 12. Now I'm actually going to bring this up to the numerator so that it becomes 3x minus 5 to the negative 2. And we want to find the equation of the curve. So to get the equation of the curve, we're going to have to integrate both sides with respect to x. Okay, so if you integrate dy dx, you get y. And then here we've got negative 12 times 3x minus 5 to the power, add 1 to negative 2, you get a negative 1, divide by the new power, so divide by negative 1, and then differentiate 3x minus 5, so that's 3, and you add your constant of integration. So y is equal to, our negative signs would cancel out here, and you end up with 12 over 3, which is a 4. And I'm going to bring this 3x minus 5 to the negative 1 down to the numerator, so that is just 3x minus 5 here, plus our constant. To evaluate our constant, we can use the point that we've been given, since we know that our curve passes through this point. So it would be 2/3 is equal to 4 over 3 times 2/3, minus 5 plus c. So that's 2/3 is equal to, that's going to be 4 over, this would cancel out, so 4 over 2 minus 5, so that's negative 4/3 plus c, and so you get that c is equal to 2/3 plus 4/3, which is just 6/3, so 2. So we can say that the equation of the curve is y is equal to 4 over 3x minus 5, and then we're replacing our c with 2, so plus 2, and that will be our final answer. Part B says the curve is transformed by a stretch in the x direction with a scale factor of a quarter followed by a translation of -4/8. Find the equation of the new curve. So if we're saying our original function, let's call it f of x, is equal to 4 over 3x minus 5 plus 2. That's the curve we got in part A, right? And we've got a stretch in the x direction by a scale factor of a quarter. So we can write this as f of 4x. Because remember, when you're taking your scale factor for a stretch in the x direction, you get the reciprocal. So the scale factor here is a quarter, and that's exactly what they have given us. Okay, so it means to apply the stretch in the x direction by a scale factor of a quarter, we have to replace x with 4x. So that would become f, we can say f of 4x is equal to, that's 4 over, here we're going to have 3 times 4x minus 5 plus, that's 2. So that's going to be 4 over, that's 12x minus 5 plus 2. And then we've got some translations here. We've got first the translation in the x-axis. So translation in the x-axis, remember in general, is written in the form f of x plus a. So this would be translation in the x by negative a units. Here we want to translate by -4 units, so we can write that as f of x plus 4. So it means we just want to replace this x with x plus 4 to apply that translation in the x. And then to apply transformation in the y-axis, which would be this 8 here, you're just going to add the constant outside, so plus b, in this case plus, or 8. So plus 8 here. So we want f of x plus 4 plus 8. So it means every x here is going to be replaced by x plus 4. And then at the end of our function, we want to add 8 units. So we are looking at 4 over 12. Replace x with x plus 4. X plus 4. And then finish off your function. So we've got minus 5 plus 2. And then at the end of your function, you add an 8. So it means our new equation will be y is equal to, that is 4 over 12 times x, that's 12x. Then we've got 12 times 4. What is 12 times 4? That's 48. So I write plus 48 minus 5. So that would simplify to just plus 43, right? So we can have plus 43 here. And then we've got plus 2 plus 8 plus 10. So this would be the equation of the new curve. Number 7. A geometric progression has first term 2 and common ratio r. The third, fourth, and fifth terms of the GP in that order are the first, fourth, and 13th terms of an AP. It is given that the terms are not all equal. Part A, find the value of r. Alright, so we've got a GP and an arithmetic progression. And we're told that for the GP, a is 2, and then the common ratio is r. Then we're told that the third, fourth, we'll start with the third term of the GP. So I'll write this as u3g to show that it's from the geometric progression. This must be equal to the first term of the arithmetic progression. So it must be equal to u1a. Okay, and we know that the fourth term of the GP, so u4g, must be equal to the fourth term of the AP, so U4A. And then finally, the fifth term, U5G, must be equal to the 13th term of the AP, so U13A. And we have to use this information to somehow find what our R is. So for a GP, remember the formula for nth term is UN is equal to AR to the n minus 1. And we know that for a GP, A is equal to 2. So we can just say UN in this case is equal to 2R to the n minus 1. And then for an AP, we're looking at A plus n minus 1D. Be careful, A is not equal to 2 for the AP. We haven't been told what A is for the AP. We're going to have to find that out. So U3GP, using the formula here for nth term, can be written as 2R to the 3 minus 1, so 2R squared, and this must be equal to U1A. So it must be equal to the first term of the AP, so that's just going to be equal to A. And then U4G, so the fourth term for the GP is going to be, that's 2R to the 4 minus 1, so 2R cubed is equal to, that's going to be A plus 3D, using this formula here for the AP. And then U5G, that's 2R to the 4, and this should be equal to A plus 12D. And so we've got three equations here in terms of A, D, and R. And so we're going to have to solve our system of equations to find our value for R, because what we're interested in is R. So what we can do is, we know that essentially here in the first equation, we've made A subject of the formula. So A can be written as 2R squared. So we can substitute into our second and third equations and say that starting with this second equation, 2R cubed is equal to A. We're saying A is 2R squared, so 2R squared plus 3D. And then in this third equation here, we can also substitute A and say that 2R to the 4 is equal to 2R squared plus 12D. Notice how now we end up with two equations in terms of R and D, and we can solve these simultaneously to get our value for R. And so since we want R, it means it's probably best for us to make D the subject of the formula so that we end up solving for R. So I'm going to say 3D is equal to, that's 2R cubed minus 2R squared, and then we're going to divide through by 3. So D is equal to 2 over 3R cubed minus 2 over 3R squared. So we can replace this D that we have here with 2 over 3R cubed minus 2 over 3R squared. So that means 2R to the 4 is equal to 2R squared plus 12 multiplied by our 2 over 3R cubed minus 2 over 3R squared. And now we need to expand and simplify. So 2R to the 4 is equal to 2R squared plus, here we've got 12 times 2, that's 24 divided by 3. So that's going to be 8R cubed. And then we've got the same situation, but for R squared, and it's negative. So negative 8R squared. All right, so let's simplify. We've got 2R to the 4 is equal to 2R squared minus 8R squared. So that gives us negative 6R squared plus 8R cubed. Let's put everything on one side. So you get 2R to the 4 minus 8R cubed plus 6R squared is equal to 0. And I can see that 2 will be common in all three terms, so we can factor out a 2. And R squared is also going to be common in all three terms, so we can factor that out as well. So that's going to become R squared minus, that's 4R, and then this 6R squared just becomes positive 3. And this is equal to 0. So here we end up with either 2R squared is equal to 0, so this part, or R squared minus 4R plus 3 is equal to 0. So this here would mean that r is 0. If r is 0, it will just mean that all your terms are going to end up being equal, and we've been told that our terms are not all equal. And so we can discard r is equal to 0, so it means our r must come from this equation here. So r squared minus 4r plus 3 is equal to 0. Let's solve that. We can factorize it as r minus 3, r minus 1 is equal to 0. So I get either r is 3 and r is 1. Okay. And if r is 1, you're going to end up with your terms being equal as well. Because if the first term is 2, you multiply by 1, you get 2. You multiply by 1, you get 2. You multiply by 1, you get 2. You get the idea. The common ratio here is times 1 times 1. We end up having all our terms being equal, which again is a problem. We've been told that our terms are not all equal. So it must mean that therefore r is equal to 3. And that's going to be our final answer. Part B. The sum of the first 8 terms of the geometric progression is denoted by G8. The sum of the first terms of the arithmetic progression is denoted by S50. Find the value of S50 minus G8. Alright, so let's start by finding G8. So to find G8, we have to use the formula for sum of first n terms for a GP, which I would just say Gn must be equal to, that's a times 1 minus r to the n over 1 minus r. And we want G8, so G8 is equal to, remember from part A, our A was 2 and we evaluated r to be 3, so it means that this is 2 times 1 minus 3 to the power 8 over 1 minus 3. So G8 is going to be equal to, let's punch this into the calculator, that is 2 times 1 minus 3 to the power 8 over 1 minus 3. So we get G8 is 6,560. And then we need to find S50 as well. So S50, this is for an AP, so we use the formula for sum of first n terms for an AP, which is half n times 2a plus n minus 1d. Okay, so we don't know what a is, we need to find that. We know that we want S50, so n is going to be 50, and then we also need to find our common difference. So going back to part A, we know that a must be equal to 2r squared. Okay, so this means if a must be equal to 2r squared, we know that r is 3, so a is therefore going to be 2 times 3 squared, so a is 2 times 9, which is 18. Then we also need to find our common difference, d. For that we can use one of our other equations, or in fact we can use this one here, where we made d subject of the formula. So we're saying that d is equal to, that was 2/3 r cubed minus 2/3 r squared. Let's just check to see if I've copied that correctly. Yes. So that means d is going to be equal to 2/3 multiplied by r, which is 3 cubed, minus 2/3 multiplied by r squared. So d is going to be equal to, let's punch this into the calculator, that's 2 over 3 times 3 cubed minus 2 over 3 times 3 squared, and this gives us d is 12. Now that we've got a is 18, d is 12, and we know that n is 50, we can simply substitute into our formula. So S50 is going to be 1 over 2 times 50 times 2 times a, which is 18, plus n minus 1, so 50 minus 1, multiplied by d, d being 12. So S50 is equal to, let's punch this into the calculator, that's 1 over 2 times 50 times 2 times 18, plus that's 50 minus 1 times 12, and this gives us 15,600. So it means S50 minus G8 is going to be equal to 15,600, which is our S50, minus our 6,560, which is our G8. So punching that into the calculator, you get 9,040, and that is our final answer. Number 8. The functions f and g are defined as follows, where k and l are constants. F of x is equal to 2 minus 3k over x plus k for x is greater than negative k. G of x is equal to lx plus 5 for x is an element of all real numbers. Part A. Given that f of 6 is equal to 4 over 5 and gf of 4 is equal to 4, find the values of k and l. Okay, so let's start by evaluating f of 6. So f of 6 is going to be, we're replacing every x with a 6. So that's 2 minus 3k over 6 plus k. And we're told that this should be equal to 4 over 5. So 2 minus 3k over 6 plus k must be equal to 4 over 5. Alright, and then we're also given gf of 4 is equal to 4. So let's start by finding gf of x first. Gf of x. So what this means is that you're going to replace this x in g with f of x. So this x that you see is going to be replaced by 2 minus 3k over x plus k. So this is L times our f of x, so 2 minus, that's 3k over x plus k, and then we've got the plus 5. And now let's replace our x with a 4. So gf of 4 is going to be our L times 2 minus 3k over 4 plus k plus 5. Okay, and we know that this L times 2 minus 3k over 4 plus k plus 5 must be equal to 4. I think the best way to go about this is to solve for k using this equation, and then once we've got k, we can substitute it into the second equation to then find L. So for starters, we're going to multiply through by 5 to get rid of this denominator here. So that's 2 times 5, which is 10. Then we've got 5 times negative 3k, so negative 15k over 6 plus k is equal to 4. And then I'm just going to put the 10 and the 4 on one side so we can simplify them. So you get 15k over 6 plus k is equal to 10 minus 4. So you've got 15k over 6 plus k is equal to 6. Multiply both sides by 6 plus k to get rid of this denominator. So you get 15k is equal to 6 times 6 plus k. So this means that 15k is equal to 6 times 6, that's 36. 6 times k, that's 6k. So you get 15k minus 6k is equal to 36, which means that 9k is equal to 36. So divide both sides by 9, you get k is 4. So now that we know k is 4, we can replace our k here with 4 so that we can solve for L. So it becomes L times 2 minus 3 times 4 over 4 plus 4. And this is plus 5 equals 4. So this is L. Then I'm just going to punch this expression into a calculator. 2 minus, that's 3 times 4 divided by 4 plus 4, which gives us 1 over 2. And then we've got plus 5 equals 4, plus 5 equals 4. So you get half L is equal to, move the 5 that side, so 4 minus 5 minus 1, multiply both sides by 2. You get that L is equal to negative 2. And this would be our final answer. You can conclude that therefore K is 4 and L is negative 2. And then part B says, for the rest of this question, you should use the value of k which you found in A. Okay, so that implies that our function f of x becomes, because we've got f of x is equal to 2 minus, what's that? That's 3k over x plus k. 3k over x plus k for x is greater than negative k. So that's so. X greater than negative k, yes. So what this means is that k is 4, so we can write f of x as 2 minus, that's 3 times 4, so 12 over x plus k, so x plus 4, for x is greater than negative 4. And part B says find the domain of f inverse. So the domain of f inverse is the same as the range of f of x. So if we can find the range of this function here, then that's going to be the domain of our inverse function. And to do this, I'm going to draw a sketch of our function. I'll just start with the root function or the base function of our rational functions. So all rational functions stem from 1 over x, which looks like this and like this. And the transformations that have been applied here are that we have translated in the y by 2 units. So we've shifted upwards by 2 units. Okay, so this is our line y equals 2. So shift this graph upwards by 2 units. Like that. This should be an asymptote, so right here. Okay, and then we can ignore this 12. It's a stretch in the x-axis. It's not going to be visible on a rough sketch. Okay, and then we've got this plus 4. That's a translation in the x-axis by negative 4 units. So negative 4 units, let's say x is negative 4 is somewhere here. It means we're shifting our graph to the left by negative 4 units. So this part shifts and we've got our new asymptote here, and this part shifts as well to the left like that. Alright, and then finally we've got this negative sign here. And also and before we get to this negative sign here, notice that our domain is x is greater than negative 4. So it means we can discard the left part of this graph. We don't need it. Alright, we only want greater than negative 4. Then finally we've got this negative sign. So that's a reflection in the x-axis. So if you reflect your graph in the x-axis, it's going to look like this. Okay, this will be our graph, and as you can see here, it's going to continue decreasing, 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 and so on. And on the other end here, we are approaching y is equal to 2, but we will never reach 2. So in other words, we're saying y is always going to be less than 2. That is the range of f of x. So we say the range of f is the domain of f inverse. So we can conclude that the domain of f inverse is x. Remember, domain is written in terms of x values. So x is less than 2. And that's going to be our final answer. Part C says find an expression for f inverse of x. Okay, so to get the inverse function, I'm just going to write our original function y equals f of x. That's going to be y is equal to 2 minus 12 over x plus 4. To get the inverse function, we are going to have to make this x the subject of the formula. Okay, so I'm going to move our negative 12 over x plus 4 to the other side. So that is 12 over x plus 4 is equal to our 2 here. And then the y is coming this side, so it's minus y. Okay, and then here we can just swap these two, so that we've got 12 over 2 minus y is equal to x plus 4. And so what is x? X is going to be 12 over 2 minus y minus 4. And if you don't understand how I just swapped 2 minus y and x plus 4 there, It's the same as multiplying both sides by x plus 4, so that you get 12 is equal to 2 minus y multiplied by x plus 4, and then going ahead and dividing both sides by 2 minus y. So at this stage, if you divide by 2 minus y, you then end up having these two brackets cancelling, and you end up with 12 over 2 minus y is x plus 4, which is this stage here. All right, and then we'd get x is equal to 12 over 2 minus y minus 4. So we can conclude that our inverse function, f inverse of x, is going to be equal to 12 over 2 minus, instead of writing y now, you have to write x minus 4. And this is going to be our final answer. Number 9. A curve has equation y is equal to 4x to the 3 over 2 minus 1. Part A, find the equation of the normal to the curve at the point A13, giving your answer in the form y equals mx plus c. Okay, so the normal is a straight line, and to find the equation of a straight line, we need two things. We need one point that lies on that line, as well as the gradient of that line. So we already have a point that lies on that line in A13, so we need to find the gradient of our normal. So to find the gradient of our normal, we can first find dy dx, the gradient of the tangent. And to do that, we're going to differentiate 4x to the 3 over 2 minus 1. So that's going to be bring down the 3 over 2 times 4, and then x, 3 over 2 minus 1, that's going to be 1 over 2. If you differentiate a constant, you are going to get 0. So dy dx, we get to be, that's going to be 6x to the half. All right, and we want to find the gradient at x is equal to 1, because that's the x value at a. So the dy dx is going to be equal to 6 times the root 1, or 1 to the power half, which is just 6. So this is the gradient of the tangent at a. We want the gradient of the normal. So we can use m1 times m2 is equal to negative 1, which must mean that the gradient of our normal is going to be negative 1 divided by 6, because it's m1 is equal to negative 1 over m2, and in our case m2 is 6. So once we have the gradient of the normal, we're going to say y equals mx plus c, and we know that this passes through the point A13, and it has a gradient of negative 1 over 6. So we can substitute and say our y is 3, x is 1, m is negative 1 over 6. So 3 is equal to negative 1 over 6 times 1 plus c. So c must be equal to 3 plus 1 over 6. So c is equal to 19 over 6. And so therefore, the equation of the normal to the curve at the point A in the form y equals mx plus c is y is equal to negative 1 over 6x plus 19 over 6. And now we're told that a point is moving along the curve y is equal to 4x to the 3 over 2 minus 1 in such a way that at A, the rate of increase of the x coordinate is 0.5 centimeters per second. Part B, find the rate of increase of the y coordinate at A. Okay, so we're given that the rate of increase of the x coordinate, that's dx, and this is the rate, so dx dt is equal to 0.5. All right, and we want the rate of increase of the y coordinate, so we want dy dt, and all of this is happening at the point A, so A has coordinates 1, 3. We can create a chain rule for dy dt and say that dy dt is equal to, that's going to be, we need a dy in our denominator, so that can come from this dy dx here. So we can say dy dx, and then multiplied by, we've got dx dt. So multiplied by dx dt, because technically dx and dx would cancel out and you still end up with dy dt. So we need to find, in fact, we've already found dy dx at x is 1 to be 6. So it means that dy dt is going to be equal to, we know that dy dx is 6, so 6 multiplied by, now we've been given that dx dt is 0.5, so times 0.5. And so this gives us that dy dt is equal to, that's half of 6, so 3 centimeters per second. That's the rate of increase of y at A. At A, the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of the y-coordinate is constant at 0.8 centimeters per second. As the point moves down the normal, find the rate of change of its x-coordinate. So now we want dx dt. So we're going to have to create a chain rule again. And this chain rule is going to be formulated using, here we've been given that dy, and remember this is rate, so it's going to be dy dt is 0.8, but be careful, this is a decrease, it's not an increase. So for a decrease, it's negative 0.8. And then we can also use dy dx. But be careful here. In this case, because we're moving down the normal, dy dx is referring to the gradient of the normal, not the tangent. In the previous example, our dy dx implied that we're moving down the tangent. But now they've specified that we've changed our direction and now we're going down the normal. So our dy dx refers to the gradient of the normal. And the gradient of the normal we calculated in part A. What was our gradient? The gradient of the normal is negative 1 over 6. Because remember, everything is still happening at the point A. Right? So it means that gradient from part A is still the same, negative 1 over 6. Okay? And so we can say dx dt is equal to, we're going to use our chain rule. We're going to create a chain rule for dx dt and say that we want a dx in the numerator, so that will come from flipping our dy dx. We can flip dy dx so that it becomes dx dy, and what you do on one side you do on the other, so we can flip the right hand side so that it becomes negative 6 over 1, which is just negative 6, right? So I'm just going to get rid of this, and so dx dy is negative 6. So you can say that dx dt is dx dy multiplied by our dy dt, because this can technically cancel out to give us our dx dt. And now we can just substitute in to get our dx dt. So dx dt is equal to dx dy being negative 6 multiplied by dy dt being negative 0.8. So you get that dx dt is therefore equal to, let's punch this into the calculator, negative 6 times negative 0.8, that gives us positive 24 over 5, and that is our final answer. Number 10, part A. By expressing negative 2x squared minus 12x minus 14 in the form negative 2 times x minus a squared plus b, where a and b are integers, find the coordinates of the vertex of the graph with the equation y is equal to negative 2x squared minus 12x minus 14. So essentially they just want us to complete the square for this. So we've got negative 2x squared minus 12x minus 14. So I'm going to factor out a negative 2 from the first two terms. So that's negative 2x squared. Be careful with the sign. It's going to be plus 6 minus 14. And now what we want to do is we want to complete the square for x squared plus 6. So it's going to be negative 2. And then we complete the square. So divide 6 by 2. It's x plus 3 squared minus our 3 squared. So minus 9. Alright, and then we've got minus 14. Now let's expand. So minus 2 times our parenthesis, negative 2, x plus 3 squared, let me write that properly. Then we've got negative 2 times negative 9, that's positive 18. And then we've got our minus 14. So you get negative 2x plus 3 squared plus 18 minus 14, so plus 4. And this would be our final answer. They also want the coordinates of the vertex, so that's the turning point. The coordinates of our vertex are going to be equal to, it's -3 and 4. Okay. And then part B says the diagram shows part of the curve with the equation y is equal to -2x squared minus 12x minus 14, and the line with the equation y is equal to -x minus 2. Find the area of the shaded region. Okay, so to get the area of our shaded region, we first need to know what the x coordinates at these points of intersection are. And once we have those x coordinates, we can integrate using them as our limits. So let's first solve our two equations simultaneously to get our points of intersection. So we've got y is equal to -2x squared minus 12x minus 14, and we've got y is equal to, that's -x, -2. So we can equate this part to this part and say -2x squared minus 12x minus 14 is equal to -x minus 2. And now let's put everything on one side. So I'm going to move everything on the left to the right. So we end up with positive 2x squared, positive 12x minus x, positive 14 minus 2 is equal to 0. So I've got 2x squared and then 12x minus x, so 11x, then 14 minus 2, so positive 12, and this is equal to 0. Alright, and I think we can factorize this by side. So x here equals 0. So we could do a positive 4, positive 3. It's 2x times 4 gives us 8x plus 3 times x. So that's 8x plus 3x, which gives us 11x. And then 3 times 4 is 12. Okay, so that's fine. Again, if you can't factorize, you can just use the quadratic formula. But make sure to show the step where you're substituting. So the x is equal to minus 11 plus or minus the square root of, that's 11 squared minus 4 times 2 times 12 over 2 times 2. They need to see this, you get our mark. That would be the equivalence of showing that factorization step there. So here we're going to get 2x plus 3 is 0, or x plus 4 is equal to 0. So you get 2x is equal to -3. So x is equal to -3 over 2. And then here you get x is -4. Okay, so it means our x coordinate here, that's the smaller x coordinate, which is -4. And then our x coordinate here would be the -3 over 2. -3 over 2. Now that we know our x coordinates at the points of intersection, we can go ahead and integrate. Alright, so this means we are integrating from our lower limit, which is the -4, all the way up to our upper limit, which is the -3 over 2. And we are integrating, it's going to be our curve, because the curve is on top, we want the area under the curve minus the area under the line. Okay, so it's going to be -2x squared minus 12x minus 14, that's the curve, minus the line. Because the limits are going to be the same, we can put them under one integral sign. So I can just subtract the line from the curve. So minus, our line is -x, -2, and this is all with respect to x. So that's the integral from -4 to -3 over 2 of, that's -2x squared. Then here we're going to have -12x, -x, so that's -12x plus x, which gives us a -11x. Then we've got -14, -2, so -14 plus 2, which gives us a -12. And this is with respect to x. Alright, so let's go ahead and integrate. We've got -2x squared, so that's -2x. Add 1 to 2, you get 3. Divide by this 3. Then -11x, add 1 to 1, you get 2. Divide by this 2. And then -12 That's technically x to the 0. So add 1 to the 0, you get 1 divided by 1. So that would still be the same. And we are going from negative 4 all the way up to negative 3 over 2. Okay. And now we can substitute in our limits. We'll start with the upper limit, which is our negative 3 over 2. So that's cubed, minus 11 over 2. That's negative 3 over 2 squared, minus 12. And that's times our negative 3 over 2. And minus our lower limit. So negative 2/3 times negative 4 cubed minus 11 over 2, negative 4 squared minus 12 times negative 4. Okay, so we'll start by evaluating the expression for the upper limit. So that's going to be negative 2/3 times negative 3 over 2 cubed minus 11 over 2 times negative 3 over 2 squared minus 12 times negative 3 over 2, and this gives us that's 63 over 8. Then we've got this minus sign, and now let's evaluate our lower limit. So that's negative 2/3, and this is being multiplied by our negative 4 cubed minus 11 over 2 multiplied by our negative 4 squared minus, that's 12 times minus 4, and this gives us 8 over 3. So our area is therefore going to be equal to, that's 63 over 8 minus 8 over 3, and this gives us 125 over 24, and that is our final answer. Number 11. The equation of a circle C1 is x squared plus y squared minus 2x plus 6y minus 6 is equal to 0. Part A. Find the coordinates of the center of the circle and the radius. So to be able to find the coordinates of the center of the circle and the radius, we want to rewrite our equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared, where a, b is the center, and then our radius is r. And so the way we're going to do that is first we group the terms that have x together. So we want to have x squared minus 2x, and then group the terms that have y together. So plus y squared plus 6y. And then any constants, you want to move them to the right. So the negative 6 moves to the right and it becomes positive 6. Then what we're going to do is to complete the square for each bracket that you have. So we start with the bracket containing the terms in x. So if we complete the square there, it's x minus 1 squared minus 1. So if we complete the square here, it becomes y plus 3 squared minus 9 is equal to 6. Then move all the constants to the right hand side so that you've got x minus 1 squared plus y plus 3 squared is equal to 6 plus 1 plus 9. So I'll write it on the side. It's x minus 1 squared plus y plus 3 squared is equal to, if you add up all your constants, you should get 7 plus 9, which is 16. And so we can write this as x minus 1 squared plus y. We want to see this negative sign, so I'm going to write this as minus 3. This is squared, and this is equal to 16, which is 4 squared. All right, so the coordinates of our center are going to be a, b. So that means the center is going to have coordinates 1 and negative 3. And our radius is going to be 4. Okay, so this is our final answer here. And then moving on to part B. Now we're given that the circle C1, which is this circle, is translated by negative 4, negative 4 to give circle C2 as shown in the diagram. Find an equation of the circle C2. Okay, so we've got our center at, what's our center? Our center is 1, -3. So somewhere here, we've got our center for C1 as 1, -3. And then they've applied a translation. Says -4 units in the x-axis and -4 units in the y-axis. So we can translate by -4 units in the x-axis to somewhere here, and then -4 units in the y-axis. So this here is -4, and this is also -4. So what that means is that we've got our coordinates of our original center, which is C1. And now let's apply the translation in the x, which is -4 units in the x. So that's 1 -4. And then in the y-axis, we're also translating by -4. So it's going to be -3, -4. And so it means our new center is going to be at -3, and then -3, -4 is -7. So this new center is -3, -7. Now, because the only transformation that I have applied here is a translation, it means that the radius should still be the same. So we can write the equation of the circle C2 as, remember, any circle can be written in the form x minus a squared plus y minus b squared is equal to r squared. So in our case, it's going to be x minus 3. So x plus 3, and this is squared, plus y minus 7. So plus 7. This is squared. The radius is going to be the same as the radius of C1 because the only transformation was a translation. So our radius is 4. So this is equal to 4 squared. So we can give that as our final answer. Now we're given that the two circles intersect at points R and S. Part C, show that the equation of the line RS is x plus y plus 6 is equal to 0. Alright, so we've got a point R here, and we've got a point S here, and we want to find the equation of this line RS. I want you to notice how this line RS is a perpendicular bisector of the line through our centers. Let me get that straight. So it's bisecting this line through our centers, and it is also perpendicular to that line. So it's a perpendicular bisector. So it means this distance here is equal to that distance here. So essentially all we have to do is to find the equation of our perpendicular bisector. And so to find the equation of a perpendicular bisector, the first thing we want to do is to find our midpoint. And remember, to get your midpoint is going to be x1 plus x2 over 2, so the average of your x values, y1 plus y2 over 2, average of your y values. So our midpoint is going to be -3 plus 1, -3 plus 1 over 2, and then -7 plus -3, so -7, -3 over 2, and this is -3 plus 1 is -2 over -2, so -1, -7, -3, that's -10 over 2, -5. So our midpoint has coordinates -1, -5. So that's this point over here. So we've got our midpoint, and our midpoint lies on the line RS. Remember, RS is just a straight line. To be able to find the equation of a straight line, we need a point that lies on that line as well as its gradient. So we already have a point that lies on the line in our midpoint. So what we need to find right now is the gradient of the line RS. And to get the gradient of the line RS, we can start by finding the gradient of the green line, the line through our centers. And because we know that our green line is perpendicular to our red line, we can then use the idea that m1, m2 is equal to -1. The product of gradients of perpendicular lines is equal to -1. So the gradient from the center C1 to center C2 is going to be equal to, so the change in y, -7, -3. Be careful with the negative signs there, over -3, -1, -3, -1. So gradient here is equal to Let's punch this into the calculator. This is -7 plus 3 over -3 -1, which gives us 1. And so it means that our gradient of RS is going to be the negative reciprocal of 1, which is just -1. So we've used this formula here, and we found that our gradient of RS is -1. So what that means is that we now know that our gradient of the line is -1, and we know that this line passes through the point -1, -5, which is our midpoint. So using the point slope formula, which is y minus y1 is equal to mx minus x1, we can substitute, and this is y. Our y1 is -5, so y minus minus 5, so y plus 5 is equal to m. M is -1 times x minus x1. X1 is -1, so it's minus minus 1, which is plus 1. And now let's just multiply through. So we've got y plus 5 is equal to, expand the bracket, that's -x, -1. And now to get this form that they want, put everything on one side. So that's going to be x plus y plus 5 plus 1 is equal to 0. And therefore, we should get x plus y plus 6 is equal to 0, which is exactly what they're looking for. Now part D says, hence show that the y coordinates of R and S satisfy the equation y squared plus 10y plus 21 is equal to 0. Okay, so if we wanted the coordinates of R and S, we can tell that the coordinates of R and S would be the points of intersection between our red line RS and either one of the two circles. So we can solve simultaneously the equation of our red line together with one of the two circles. We can pick one because we can tell that R and S lie on both circles. So we'll use this equation for the circle with center C2, so this one here. We're going to use that. Let me copy that, and then we'll bring it down there. Okay. And then we are saying we're solving for the point of intersection between this equation as well as this equation. So x plus y plus 6 is equal to 0. Let me just move this a little closer. All right. So what we can do is we can make, now here be careful with how you choose what to make subject of the formula in the equation of the line, because we want an equation in terms of y. It makes sense for us to make x the subject of the formula, because that means when we substitute, we just end up with an expression or an equation in terms of y. So we want to say x is equal to -y -6, and then we can substitute into the equation of the circle. So if we do that, that's going to be, replace this x with -y -6, so -y -6, then we've got plus 3, and this is squared, then we've got plus y plus 7 squared, plus 7 squared is equal to 4 squared, which is 16. And so this is -y, -6 plus 3 is -3 squared plus y plus 7 squared is equal to 16. Let's expand our brackets. So that's y squared. Be careful here, there's too many negative signs. So 2 times -y times -3, which is positive 6y. Square your -3, so that's 9. And now let's expand this bracket. So y squared plus 2 times y times 7, that's 14y. 7 squared, that's 49. And then I'll bring the 16 to this side, so minus 16 is equal to 0. And so now we want to group like terms. Y squared plus y squared, 2y squared, 6y plus 14y, 20y, 9 plus 49, that gives us 58, minus 16, that gives us 42. Okay, and this is equal to 0. And now hopefully you can tell, if we divide through by 2, we should get what they want. So divide through by 2, you get y squared plus 10y plus 21 is equal to 0. And we have shown that the y coordinates of r and s do in fact satisfy this equation. If they told us to find the actual y coordinates of r and s, then we would have gone ahead and solved this equation, but they're not interested in the coordinates themselves. They just want the equation that satisfies our y coordinates. Okay, so that will be the final answer, and that is the paper as well. I hope you guys found this useful. And if you did, please share this with others who are suffering or struggling with A-level maths. Don't be stingy. Share the knowledge so that the threshold is high. Otherwise, I wish you guys all the best in your exam. Good luck, all the best. You got this. And subscribe and like the video so that you pass. Because if you don't, there's a good chance you don't pass. Just putting it out there. Anyways, all the best.